Amid the inky expanse of the cosmos, one mysterious neighbor has beckoned us with the promise of answers to the age-old question, are we alone in the universe? Journey with us as we embark on a thrilling exploration of the red planet. Mars, a celestial enigma that has captured the imagination of humanity for centuries. Our quest will transport you through time and space, weaving a narrative that transcends our terrestrial boundaries and offers a glimpse into the profound mysteries of the Martian planet. Mars, the fourth planet from the Sun, a captivating world of vast landscapes, colossal canyons, and towering volcanoes. In fact, it's home to the largest volcano in our solar system, Olympus Mons. Mars, like Earth, has seasons, polar ice caps, and a day-night cycle. A day on Mars is similar to Earth, lasting approximately 24 hours, 39 minutes, and 35 seconds. However, there are significant differences as well. The planet's atmosphere is thinner than Earth's and consists primarily of 95.3% carbon dioxide, 2.7% nitrogen, and 1.6% argon. The largely carbon atmosphere means the planet is inhospitable to humans and lacks the protective ozone layer found on Earth. Mars's climate is also extremely cold, with average temperatures well below freezing and severe dust storms that rage across the planet's surface. And yet, despite all these factors, the appeal of Mars remains. In its planet's history, the search for life, and for the future of human expansion. Our voyage of discovery first took flight long before the era of modern space exploration, where the secrets of Mars found their way to us on the wings of ancient meteorites. Far from the reaches of the red planet's surface, these celestial messengers have carried with them the fingerprints of Martian history. But one of these cosmic travelers stands out, bearing a name that reverberates in the archives of scientific exploration: ALH 84001. The year was 1984, when ALH 84001 was discovered in the frigid embrace of Antarctica's Allen Hills. A seemingly ordinary space rock revealed itself to be something else entirely. A cosmic time capsule, preserving the secrets of Mars' ancient past, like pages in an extraterrestrial history book. In the 1990s, a group of scientists made a groundbreaking proclamation that would send shockwaves through the scientific community and captivate the world's imagination. They claim that ALH 84001 held microscopic structures resembling fossils within the meteorite. These tiny structures, mere nanometers in size, bore a striking resemblance to the bacterial life forms on Earth, particularly a class known as nanobacteria. Implications were profound. Could this be evidence of life's existence on Mars? But as with any grand discovery, the chorus of skeptics arose. They argued that the structures within ALH 84001 might have been formed through entirely non-biological processes. The conditions on Mars, even in its distant past, could have spawned mineral formations mimicking biological structures. These abiotic processes include the crystallization and precipitation of minerals in certain patterns, which can mimic the appearance of biological features. Critics also raise concerns about the possibility of terrestrial contamination. What if the meteorite during its stay in Antarctica had encountered Earth's microorganisms, tainting its Martian cargo? Regardless of the debates it sparked, this meteorite has been a compass guiding us in our unending quest to unlock the secrets of the red planet. It may not have provided definitive evidence of past Martian life, but it has breathed life into the curiosity and determination of scientists to explore this enigmatic world. The exploration of Mars took a significant leap forward with the deployment of robotic missions. Images captured by Mars rovers landers, and orbiters have painted a stunning and captivating portrait of the Martian landscape. These images reveal the stark beauty of the red planet, from its vast canyons and towering volcanoes to its layered rock formations and riverbeds. The first human-made object to reach Mars was the Soviet spacecraft Mars 3. It arrived at Mars on November 27, 1971. While Mars 3 was the first spacecraft to ever reach Mars, it unfortunately crash-landed and soon lost all communication with Earth. It was not until 4 years later that NASA would achieve a remarkable milestone, becoming the first space agency to successfully touch down on Mars with the Viking 1 and Viking 2 landers. They provided humanity with the first ever high-resolution images of the planet's rocky terrain. The Viking Landers conducted extensive soil analysis, revealing that Martian soil contains elements such as iron, magnesium, and sulfur. It was thanks to these landers that we could determine the composition of the Martian atmosphere, gain a better understanding of the planet's changing climate, and the behavior of its polar ice caps. In 1997, NASA's Mars Pathfinder mission introduced the world to the innovative Sojourner rover. This six-wheeled marvel was the first successful wheeled rover on Mars. Sojourner conducted geological investigations on Mars's surface. It found and analyzed a variety of rocks, collecting valuable data about their composition and the planet's geological history. What it found fascinated scientists. The rover located rounded pebbles at the landing site, rocks that form in the presence of running water. It led NASA to question if this site could have been a river or lake many millions of years ago. Pathfinder also recorded weather conditions, but it found something strange about the Martian dust. Like something out of science fiction, the airborne dust on Mars is magnetic. Its characteristics suggest that the magnetic material is magamite, a very magnetic form of iron oxide. Even more remarkably, the magnetic materials carried in dust grains may in fact be freeze-dried remnants of the planet's watery past. It is because of this that future Mars rovers would be fitted with magnetic targets that collect airborne dust for further analysis, along with a more powerful magnet that deflects dust away from the rover's instruments. Building on this critical infrastructure was the launch of the Mars Odyssey in 2001. This orbiter acted as a lifeline of communication for future Mars rovers, ensuring that vital data can traverse vast interplanetary distances with reliability. The orbiter was able to study the planet by mapping the chemical elements and minerals that make up the Martian surface. These findings led scientists to a monumental discovery: vast amounts of water ice in the polar regions, buried just beneath the surface. What we once believed was a barren wasteland now could potentially have been a world filled with running water. As the scientific discoveries continue to surprise and inspire humanity, the European Space Agency joined the fray with the launch of their first interplanetary mission, the Mars Express. This orbital spacecraft supported the discoveries from NASA by using its advanced radar to detect large underground water ice reservoirs on Mars. Despite the planet's current aridity, water has been a major focus of the investigations by Mars Express. One instrument has discovered hydrated minerals that form only in the presence of liquid water, providing confirmation that Mars was once much wetter than it is today, and demonstrating that conditions may, at least for a brief period, have been favorable for life to evolve. Even studies of the billion-year-old volcanoes have resulted in some surprises. Images suggesting that some of them have been spewing out lava within the last few million years. Following the Mars Express's success, NASA launched its own high-resolution imaging orbiter in 2005, labeled the Mars Reconnaissance Orbiter. Though previous cameras on other orbiters could identify objects no smaller than a school bus, this camera can spot something as small as a dinner table. This capability has allowed the orbiter to identify obstacles such as large rocks that could jeopardize the safety of landers and rovers. However, it was in 2003 that the world was captivated by Spirit and Opportunity, dubbed as the dynamic duo of Mars exploration. NASA's twin rovers were designed to embark on an extraordinary journey to uncover the mysteries of the Red Planet. These robotic explorers landed on opposite sides of Mars, and their mission outcomes far surpassed their original goals. Spirit's mission was a tale of unexpected revelation and extraordinary findings. The rover embarked on its Martian adventure by unearthing rocks that were a treasure trove of vital chemical compounds, 10 times richer than any other Martian rocks ever studied. These formations bore witness to a time when Mars was warmer, potentially rendering it hospitable to life. But Spirit's narrative took an unforeseen twist. As the rover diligently rolled along the Martian terrain, one of its wheels began to drag, inadvertently peeling back the Martian soil. What lay beneath was nothing short of astonishing: silica-rich soil. On Earth, such silica deposits are commonly associated with hot springs or steam vents, environments teeming with life. This revelation opened the door to a tantalizing possibility. Could these silica-rich patches hint at a time when ancient Martian microbes thrived in similar conditions? Opportunity, the unrelenting explorer, had greater revelations up its sleeve. The rover unveiled the existence of clay deposits and the presence of hematite, a mineral commonly associated with water-related processes. The rover's success persisted as it identified vivid gypsum veins in the rocks. However, these weren't ordinary rock formations. They were remnants of a time when water had streamed through underground fractures, leaving behind calcium-rich traces. One of the most remarkable feats of these rovers was their longevity. While their primary missions were initially planned for just 90 Martian days, both Spirit and Opportunity continued to operate for years beyond their expected lifetimes. Their remarkable durability and resilience allowed them to provide invaluable data and insight into the planet's geological history. Tragically, Spirit's mission came to an end in 2010 when it got stuck in a sand trap and couldn't reposition its solar panels to capture enough sunlight. However, Opportunity continued to explore and transmit valuable data for over a decade. It faced challenges such as dust storms that obscured its solar panels, but it soldiered on. It was only in 2018 that a massive dust storm engulfed Mars and silenced Opportunity, bringing its mission to an end. The legacies of Spirit and Opportunity live on in the wealth of knowledge they bestowed upon the scientific community. These rovers reshaped our understanding of Mars, providing compelling evidence of its watery past and paving the way for future missions. Their remarkable adventures on the Red Planet continue to inspire future generations of explorers and scientists as we strive to unravel the enigmatic history of our neighboring world. The next such explorer came in 2008 when the Phoenix Mars lander executed a dramatic landing on the Martian Arctic plains. One of Phoenix's primary objectives was to confirm the presence of water ice on Mars. It did so by using a robotic arm to dig through the Martian surface to reach a subsurface layer. The lander's robotic arm delivered the sample to an instrument that identifies vapors produced by heating those samples. "We have water," said William Boynton of the University of Arizona, lead scientist for the Thermal and Evolved Gas Analyzer. He went on to elaborate. "We've seen evidence for this water ice before in observations by the Mars Odyssey orbiter and in disappearing chunks observed by Phoenix last month. But this is the first time Martian water has been touched and tasted." The exploration of Mars took another leap forward with the introduction of the Curiosity rover, a technological marvel that represents a significant advancement in the exploration of the Red Planet. In August 2012, Curiosity descended upon Mars in a remarkable sky crane landing. Weighing nearly 2,000 pounds, Curiosity was not merely a rover. It was a mobile science laboratory, armed with a suite of scientific instruments to address key questions about the potential habitability of Mars and the planet's geological history. Curiosity found that ancient Mars had the right chemistry to support living microbes. The rover detected sulfur, nitrogen, oxygen, phosphorus, and carbon, key ingredients necessary for life, in the powder sample drilled from the sheepbed mudstone in Yellowknife Bay. The sample also reveals clay minerals and not too much salt. This suggests that fresh, possibly drinkable water once flowed through the bay. Organic molecules are the building blocks of life, and they were discovered on Mars by the Sample Analysis at Mars (SAM) instrument in several samples drilled from Mount Sharp and the surrounding plains. While these findings don't definitively prove that there was past or present life on Mars, it does show us that the raw ingredients required for life existed at one point in time. But even more thrillingly, it means that these ancient organic materials can be preserved for us to recognize and study even today. The tunable laser spectrometer within the SAM instrument detected a seasonally varying background level of atmospheric methane and observed a 10-fold increase in methane over a 2-month period. The discovery of methane is exciting because methane can be produced by living organisms or by chemical reactions between rock and water. This leads us to ask two questions. Which process is producing methane on Mars? And what caused this sudden increase? As Curiosity marks its 10th anniversary, it has achieved a significant milestone in answering a pressing question that has captivated scientists for years. Has Mars, at any point in its history, possessed the essential components required for the existence of life? Today, NASA has affirmed this question with a resounding yes. Extensive research reveals that these crucial life-sustaining elements were indeed present on the Martian surface for tens of millions of years, offering ample time for natural processes like weathering, erosion, and potentially even chemical transformations to occur. In 2013, the Mars Atmosphere and Volatile Evolution (MAVEN) spacecraft took off on a mission to explore the Martian atmosphere and the reasons behind its gradual thinning. MAVEN's research shed light on how Mars lost its once thicker atmosphere over billions of years, mainly due to solar wind and radiation. This transformation changed Mars from a potentially habitable world to the dry, inhospitable planet we see today. MAVEN also observed seasonal changes on Mars, noting variations in the concentration of hydrogen in the outer atmosphere, a crucial factor in the loss of water from the planet. At different points in its orbit around the Sun, Mars experienced significant fluctuations in this hydrogen concentration, explaining the loss of a layer of water that averaged about 21 feet deep across the entire planet. In 2013, India entered the interplanetary stage with the Mars Orbiter mission, which successfully entered Martian orbit by 2014. NASA's InSight spacecraft, landing on Mars in November 2018, had a different mission. It explored the planet's interior, delving into its three main layers: the crust, mantle, and core. By understanding these layers' composition, structure, and how heat dissipates from them, we gained valuable insights into the geological history of Mars and its ability to support life over time. InSight seismometer made a significant discovery when it detected a magnitude 4 Marsquake, later attributed to a meteoroid impact. This event marked one of the most substantial meteoroid impacts on Mars since NASA's exploration efforts began. The impact also revealed a buried treasure, an underground layer of water ice, remarkably close to the Martian equator. Ice deposits in that warmer equatorial area might serve as future landing sites for astronauts to use for drinking water, agriculture, and rocket propellant. In 2020, a unique opportunity presented itself for Martian expeditions. This period offered the most efficient launch windows for spacecraft from Earth to Mars, dictated by the relative positions of the two planets in their orbits around the Sun. Consequently, 2020 saw the launch of 3 separate spacecrafts by different entities: the United Arab Emirates, China, and the United States. The UAE made history by launching its interplanetary mission, the HOPE satellite, becoming the first planetary science mission led by an Arab Islamic country. The UAE's mission aimed to explore the connection between Mars's current weather and its ancient climate, shedding light on the evolution of the Martian atmosphere and the potential reasons for the loss of any past Martian life. Meanwhile, China embarked on its first independent interplanetary mission with Tianwen-1, a comprehensive probe consisting of an orbiter, lander, and rover. The primary goals of this mission were to study the Martian surface, its geology, climate, and atmosphere. With both agencies achieving successful orbit insertion in 2021, Mars had now been reached by 5 different entities on Earth: the United States, the former Soviet Union, the European Space Agency, India, China, and the UAE. One of the most ambitious launches, however, is NASA's Perseverance.
Let me talk to you.
We have Dr. Mohan here with me. Of course, you know her from the landing coverage.
Hey, Doc, how are you?
I'm doing very well, Mr. President. Perseverance is my first mission at JPL where I've gotten to work from the very beginning of formulation all the way through operations. Being able to work with this incredibly diverse, talented team that has become like a family, spending years creating our own technological marvel has been a privilege.
Well, I tell you what, you've created a dream for millions and millions of young kids, young Americans. What you did, you restored a dose of confidence in the American people. You guys did it. You guys gave a sense of America's back. You did it the most American way. You believed in science. You believed in hard work, and you believed there wasn't a darn thing you couldn't do if you put your minds together. One of the reasons why we're such an incredible country is we're such a diverse country. We bring the best out of every single solitary culture in the world here in the United States of America, and we give people an opportunity to let their dreams run forward. It's so much bigger than landing Perseverance on Mars. It's about the American spirit. You brought it back. You brought it back in a moment we so desperately need it. We can land a rover on Mars. We can beat a pandemic. And with science, hope, and vision, there's not a damn thing we can't do as a country. All the dreams you've created in other people's minds, other young kids. And it's only just a start.
This robotic explorer brings with it an audacious mission: the quest for signs of ancient microbial life. The rover is equipped with a diverse set of scientific instruments and a sample caching system designed to collect and store Martian rock and soil samples. These samples may be returned to Earth by future missions for further analysis, providing a potential breakthrough in our understanding of the possibility of past life on Mars. Perseverance is not alone in its journey. It carries a helicopter named Ingenuity. This airborne accomplice has defied gravity and taken flight on Mars, opening the skies to future possibilities. During its mission, Perseverance's most exciting finding relates to the history of the body of water that once filled the Jezero crater. Although the existence of such a lake was detected from orbital images acquired a few years ago, Perseverance can now add substantial detail to the crater's history. On the floor of the crater, the rover discovered igneous rocks produced by crystallizing magmas. This suggests the possibility that the crater was once filled with a lava lake. Sometime later, water theoretically flowed into the crater to produce a shallow lake on top of the igneous rock, creating salty mudflats that were likely good habitats for any Martian life that may have existed. All of this is important because it tells a story of a Mars very different from today. When the rocks Perseverance is exploring were created billions of years ago, Mars was active. It had volcanoes, lakes, rivers, and habitable environments. But today, it is cold, dry, and quiet. Bringing samples back is the best way to understand how early Mars worked and what happened to so vastly change it. The Mars Sample Return Campaign is an effort to bring samples of Martian rocks and soil safely back to Earth, where they can be investigated in unprecedented detail, using all the capabilities of terrestrial laboratories. NASA and ESA are collaborating on a campaign that would include a NASA-led sample retrieval lander, which would launch the retrieved samples aboard the Mars Ascent vehicle. Once the sample containers reaches Mars orbit, an ESA-led Earth return orbiter would rendezvous with it and bring the precious cargo safely back to Earth. While the tales of our rover companions have captured the hearts of many people back on Earth, our cosmic journey does not conclude with robots alone. The era of human exploration dawns, with NASA's Artemis program targeting the Moon as a stepping stone to Mars, and companies like SpaceX setting ambitious plans for manned missions to the Red Planet. These concepts of Martian colonies and terraforming are no longer relegated to the realm of science fiction, but are now a glimpse into our potential future. The discovery of life on Mars, should it ever occur, carries profound implications. It could inspire a renewed sense of wonder, curiosity, and unity among humans, transcending geographical, cultural, and political boundaries. As we stand on the cusp of potentially discovering Martian life, we must consider the profound implications and responsibilities that such a discovery entails. Our journey to find life on Mars is not merely a scientific endeavor. It is a voyage to explore the universe and to unravel the profound mysteries that surround us. Our journey to the Red Planet is a song of humanity, echoing across the cosmos. A reminder that the stars hold answers that could forever change our perception of the universe and our place within it.